Hi friends, welcome to this next session. Now let's see what the policy gradient methods are and the details about the policy gradient methods used in reinforcement learning. So the policy gradient method are one which directly optimize the policies and are very much useful when we have continuous actions. That is, when the actions are in continuous domain, then it is better to work with a policy rather than the value-based methods. So in this method, we compute the gradient of the objective function j of theta, where theta is some policy parameter and j of theta is an objective function which we would like to maximize. So in our case, this objective function may be the reward. So we would like to maximize the rewards. So we want to identify the best policy parameter theta that maximizes the rewards j of theta. So that's a idea behind the policy gradient method. So here we are given with a policy phi that is parameterized by some thetas, and the goal here is to optimize the objective function j of theta, which is the expected value of the total cumulative rewards from now, that is at time t onwards. So from t onwards, whatever rewards are expected, so sum up them all. So the cumulative expected rewards from now or from time t onwards are to be measured, and the goal is to maximize this objective function. So j of theta is our objective function, which is a cumulative reward maybe. So we would like to make sure to have highest reward possible from now onwards till we end the game. So looking at the algorithm, so first let's see what the overall system of policy gradient method looks like. So we have an environment and then we have an agent. The agent has two components. One component, that's a policy, and the other component is a reinforcement learning algorithm. So the policy agent has got some policy, and it reads the environment, it observes the environment at any given time t, and that is fed to the policy, and the policy will decide what action a of t to be taken at time t. So the action at any given time t depends upon what is observed in the environment and the current policy. So these two together will decide what the action to be taken by the agent, and this action is taken, and because of this the environment changes its state and will produce a reward r of t. So this r of t is fed to the reinforcement learning algorithm. So this reinforcement learning algorithm has information like what was the previous observation, how the environment was looking before and what action was taken, and for that previous environment, for the current action, what changes happened with the environment and what reward was gained. So taking all these into consideration, that means for the current environment, for the given action, what was the reward and how the environment changed. All this information go into the reinforcement learning algorithm, and that will update the policy. So the policy is updated such that the next time if we get the same combination, that means if we get the same observation and if we have action, some action, so that the reward would be better than the previous one. That means next time when we come across with the same environment, and then we should be able to take a better action so that it can provide a better reward. So this change in action for a same state q of t should depend on the policy, and this policy keeps updating depending on what happened with the action, and after the action what was the reward. Did we move towards the goal state or did we move away from the goal state, and that is going to tell us through the reward and this cumulative reward. And this is useful in the policy, will try to foresee what could happen if a particular action is taken. So it just foresees the cumulative effect and then uh, provides the best possible action. And for that action, there will be reward, and this reward will be fed to the reinforcement learning algorithm. And if the reward is not satisfactory, then the policy will be updated. And because of this, better actions will be taken. And because of better actions, better rewards are expected. And because of this, the whole system, because of this feedback, the system tries to learn better and better activity. So let's look at the algorithm. Uh, so here, the first thing happens is the agent interacts with the environment with the following a current policy. So there is some policy. So using that policy, the agent interacts with the environment. So it collects the state and the action and the rewards. So agent interacts with the environment using the current policy, and because of that there will be action, and because of action there will be change in the state, and there will be rewards produced. So here g of t is the cumulative reward obtained from time step t onwards. So that is from t onwards, what are the reward expected. So this is often computed as a discounted sum of rewards because we want to reach the goal as early as possible. So to make sure that we reach the goal as early as possible, the best way is to have some discounted sum of rewards so that the direct path will get us direct higher rewards. If you take a longer path, then it will be fetching a smaller rewards at each step and so on. Then the gradient of this objective function with respect to the policy parameters is computed, using the collected data. And then the policy parameters are updated using the gradient ascent to improve the expected return. So what is this gradient? So gradient is the one which gives the direction in which the function is increasing. So the gradient of any function is the direction in which the function value keeps increasing. So we just look at that gradient direction and we change our parameter values in that directions so that the next step we will be even more closer to the goal state than getting randomly away or any other place. So it's systematically what we are doing is we just identify the objective function and then find its gradient. So the whole aim of this is to make sure that we get a highest objective function value. That means we want a global maxima of the objective function. So to reach the global maximum, what we can do is on the objective function surface, we just find the gradient at the point where we are currently and find the direction which tells us when the objective function is increasing and we keep moving in that direction. That means our parameters are moved in smaller steps in that direction so that from time to time, iteratively, we can keep moving. So we can change our parameters, policy parameters, so that sometime later we reach the maximum. So that's the idea of policy gradient method. The other method is proximal policy optimization, in short called PPO. So this is gives us a stable policy updates. So here this is again same as the previous one, gradient method, but only difference is here the objective function is clipped between the two ends. So they, the objective function always lies between within a safe range. So it will prevent sudden rise in that, so that the updations become destabilized. Now, what happens is whenever we have a objective function, which is a mathematical function, and we come across with a problem like computation. So to identify the gradient, what actually we do is we try to find the slope slope of the uh, tangent slope of the tangent to that surface at that given point. And if the uh, tangent is vertical, then the slope of that becomes infinite. So when the slope becomes infinite, then we no longer will be able to continue our work because numerically the value becomes infinite, means it's the whole activity gets stuck. So we just don't want to get stuck somewhere. So to make sure that our values, especially the gradient values, are in the safe range, so we clip it. So this is done by the method called proximal policy optimization (PPO). So this will avoid destabilizing the updates. So this is one of the most popular and robust policy gradient methods when we have highly complex environments. The other one is actor critic technology. So this is a combination of both policy based as well as value based methods. In this, actor is a network that learns a policy. A policy is nothing but a function that maps states to the actions. So from every state, action that can produce the best results. So there is a mapping, and this mapping is what we call a policy. So for any say policy, so from every state of the environment, we have identified as of now the best action. So that's what we call a policy. And here the actor selects the action based on the current state and as of now, what is the learned policy. So looking at that, some action is taken. And once the action is taken, definitely the environment is going to be disturbed. So it changes. So then there is another network which is called critic, and this network learns a value function. Now, what is value function? It's estimate the expected cumulative reward for a given state or the state action pair. So we are at some particular state. From this state onwards, if we continue with this given policy, then where all we can lead to, so that gives a value function. So we get a value for that, and this critique evaluates the actor's action and provides a feedback on their effectiveness. So how well the actions were taken. So if you look at this figure, we have an environment, then we have an actor. Actor is a policy. So actor is associated with a policy. There is some policy, and the environment is at some particular state, and the state is fed to the policy, and that policy will decide for that current state what is the best action, and that best action is taken, and that changes the state of the environment and also produces the reward. Now critic is another function which looks at the current state, which looks at the previous state, and sees what was the reward. So changing from current state to the next state, what happened with the reward. So in the current state, last time what was the reward, in the current state, this time what is the reward, did it improve or not. So in the same state, last time some action was taken, so we had some reward, and then the later in some other time, if we are in the same state and now we take some other action, definitely the reward is going to be different. So we are going to compare the two rewards in the same state. So last time in state S1, what was the reward for some action A1? Now we are back to same state S1 after some rounds, and then after a change in the policy, now some other action A2, might be taken, and because of A2 we get another reward. So last time what was the reward? This time what is the reward? Is this going in positive direction or going in negative direction? So that is the temporal difference between the rewards. So the previous reward, current reward, the difference between them for the same state is computed, and then the feedback is given both to the critic as well as actor. And looking at this temporal difference in the reward, looking at this feedback, the actor will update the policy so that when we our environment is in the same state again next time, we should be able to find a better action, so that we should keep improving ourselves, improving our skills with time. So that's overall what is what we want. So as we keep learning with time, our skills improve. The same thing we want our machine also to do it. So here the critic helps reduce the variance provided the feedback in the form of advantage function, that is the difference between the expected return and the state value. So for every state there is a value defined by the critic, and what is expected return, that is the reward, and this difference is to be reduced. So we want the variance to be reduced. So how this whole algorithm looks like? The first thing is the actor start taking action on the environment based on the current policy. Some policy is decided, and based on that policy, the actor will take some action. So because of this action, definitely the state of the environment is going to change, and the environment is going to produce a reward function. So for the given action, some change in the environment, and because of that, there is some reward. Now this reward, as well as the state action pair, is studied by the critic, and it evaluates and estimates the expected return, or in future what the rewards could be. And this critic uses this value function and provides feedback to the actor, and saying that whatever action was taken now was good or bad. If it is good, then the actor is encouraged to take similar actions more often, and if it is bad, then actor should update the policy so that in future similar actions are minimized. So now, looking at this feedback, the actor updates its policy based on the critic's feedback, and overall the aim is to improve the actions from time to time. So that's what we call learning. Yeah, that's about the different types of reinforcement learning techniques. Now the thing is, should we start implementing these techniques directly onto the real world, or should we just do some study on a simulation and then get into real world? So that's what we need to look at. Both has got its own pros and cons. Directly jumping into the real world is having some sort of problems, or getting into simulation and then jumping to this also has some sort of pros and cons. So more details to follow in the coming sessions of this series. So keep watching. Don't forget to like and tell your friends regarding this session and this series. Please do share. Thank you.